Hi, everybody. This is Monica Paolini from Senza Fili, and today we're talking about a Terragraph network in the US. And I have the pleasure to talk to Brett Bonomo, who is the CEO of Castle Rock. And he has been building a Terragraph network already. But I'm not going to spoil the story. I will let him tell you. So Brad, thanks for sharing your thoughts with us today.
Thank you, Monica. It's a pleasure to be here.
Okay, so well, let's first let people know who you are and what you're doing at Castle Rock.
Yeah, Castle Rock Microwave is a regional wireless systems integrator, and we get involved in the design, procurement stages, and deployment and maintenance and monitoring of broadband wireless systems throughout the state of Colorado and the neighboring states. We work primarily with public safety agencies, utility companies, rural broadband operators, as well as Class 1 railroad companies.
That's a lot of verticals right there. And so interestingly, you're coming from microwave. So what got you interested in Telegraph?
Without a doubt, the driving factor is always capacity. Our customers tend to want more and more capacity than what is necessarily available in the microwave frequency bands. And we have felt a regular pull towards millimeter wave frequencies. And Terragraph is an obvious solution just because of the economies of scale that have been created and provided to us through major companies getting involved, as including chipset manufacturers, to help reduce the costs.
So clearly there's a lot of spectrum, but it's also unlicensed and the reach is limited. Is that an issue at all for you?
For some of our customers, certainly, and their applications, it could be. But the sweet spot for us right now, as it relates to these millimeter wave solutions, are municipal networks. And we are seeing applications in hospitality, as well as some of our rail customers and public safety agencies, because they have applications where the distances are not great and very high bandwidth requirements driven by things like video, Wi-Fi, public Wi-Fi access, and other just enterprise LAN extension needs.
Yeah. Well, sometimes the short reach is a good it's a good thing because it means more reuse and less interference if you're using unlicensed bands. So let's talk about the network you got going. That's a very interesting. That's a very cool story you have to say. So,
Yeah. So we were engaged with the city of Aurora, Colorado, which is the state's third largest city, and they have a very diverse mix of demographics throughout their community, and it's created some interesting needs, especially in COVID, to provide high-speed connectivity to certain locations to help facilitate distance learning for children with working parents and who would otherwise be unsupervised if left at home. We've been working with the city for several years, deploying and maintaining microwave radio links and enabling high-speed connectivity to some of their different buildings throughout the town and facilities. In addition to not just the traditional IT, enterprise IT group, but also the water department and some of the other departments within the city. We were in the process of evaluating roughly 30 links to be upgraded and replaced for the city. And because of the funding created through the CARES Act, all of a sudden at the end of last year, there was a huge rush and opportunity to leverage that budget, that financing, to upgrade these links, because again, they were going to some places that badly needed it to enable some connectivity they had never needed before. So we engaged with Cambium and their 60 gigahertz Terragraph product to start to replace many of these links, most of them short, most of them less than half a mile. We had, of the approximately 30 links, 10 of them were over half a mile, and we used 70, 80 gigahertz licensed solution at 10 gigabit per second for that. But by and large, we really leaned into 60 gigahertz for the much shorter links, and we are providing about 1.8 gigabits per second of connectivity. These facilities include different enterprise office buildings that belong to the city for different administration things, fire stations, police-related facilities, many parks where there's public Wi-Fi, and then also some recreational centers. And some of these, like I said earlier, some of these facilities are set up to allow children to come who shouldn't be staying home alone or because it's not safe, and have a place to go and experience kind of a distance learning in a socially spaced environment.
So in this case, for the kids, you basically use a Terragraph as a sort of backhaul to a Wi-Fi, to the Wi-Fi local network, right?
Yes.
Okay, and so and then you use the same. Is it the same Terragraph network that is used both for those public areas where the kids go and parks and all the other? I mean, it's just basically shared across different applications. Is that right?
That's right.
And so how actually, can you tell me how big is the network? How many nodes you have? And
yeah, so there's approximately 30 locations that are touched with this wireless network. The city itself probably has hundreds of assets, and many of them sit on fiber. So the point with the wireless links is to get back to a fiber drain site or a fiber location as quickly as possible. And that's what we're doing with that. And the network supports all kinds of enterprise LAN applications, server-based applications, credit card processing for some of their locations that are involved with the recreation, and then of course support of public Wi-Fi.
So I guess that for them the cost is not that high if they have the fiber transport network that they can leverage to provide. So they basically need the local connectivity, the short range connectivity, where it would be really difficult to have fiber to every Wi-Fi access point.
That's right. And the beauty of the Terragraph method and capabilities, we're not using it now, but the ability to do mesh provides us, or will enable us in the future, to add nodes very quickly and cost effectively. Should the city ever decide to, and they've never suggested this, but should they ever decide to branch into some kind of bigger operations or service operating arrangement, some cities are looking at public-private arrangements to provide greater connectivity and backhaul for folks like cellular providers, but that capability is in the solution, so that we could literally just add nodes and build out the network very quickly.
Mm-hmm. So right now it's would you describe it as a sort of basically a point to multipoint type of network?
It very much is. Yeah, we are using the Terragraph solution for many point-to-point links, as well as point to multipoint.
Yeah, but then you have all the structure in place so that you can introduce the mesh functionality anytime you need it.
That's right.
That's what kind of use cases? I mean, what would say at which point you would recommend to the city? Okay, now it's time to use mesh.
Again, if there were an opportunity for a service provider to come in and say, "Hey, we really need backhaul," or maybe even one of their other stakeholders within the city, one of their groups, and I'll say, for example, again, this hasn't been discussed exactly, but the traffic division. If the traffic division decided we really need this connectivity on all of our light posts today, by the way, they use unlicensed 5 gigahertz radios to do that in a very large point to multipoint fashion. But if we start thinking about Terragraph as a means for like IoT backhaul or signaling backhaul, we could start setting mesh nodes on traffic signals. And in our experience working with other municipalities around the state and outside of our state, we are seeing more acceptance of multiple departments using the same infrastructure. And you think, well, of course, I mean, why wouldn't they're the same city? It's simply not the case. I mean, there are great barriers between different divisions in any given city, especially a large city. But now we're starting to see them start to converge more. So we can imagine that for large cities like this, it will make sense to start to add these mesh nodes on traffic signals and light poles to enable things like traffic control, or what they call electronic security, which is oftentimes a function of a police department to provide video surveillance for certain needs or events throughout the course of, or throughout the area of the city in different events. And having this functionality in a very big fat pipe of data available to them could be potentially huge.
Yeah, and I guess that, the denser the network, the more advantage you take of a mesh. The mesh becomes much more valuable when you have a dense network, multiple applications, because then you can manage traffic. So that's quite interesting. Now, what did you learn? I mean, being one of the first to go and deploy this in a network that it's used. It's not a trial. It's a real life.
It's in production.
Let's use it. So, what is that you learn as you were going through the deployment?
Yeah, so having a strong background in microwave, millimeter wave is absolutely different. It certainly requires special consideration and additional thought as it relates to distance. The distances are shorter. We're using 60 gigahertz on paths less than half a mile or less. We've got a couple that are just a little bit over that half mile range, but by and large are less than half a mile. There are special network considerations. We're no longer dealing with simple 10/100 megabit per second Ethernet ports or even gigabit Ethernet ports. Now we need multi-gigabit Ethernet ports, either 2.5 gigabits per second or 10 gigabits per second. So the network infrastructure needs to support this. And then, of course, there's the aspect of IPv6, and I don't know exactly how all the different manufacturers deal with IPv6 versus IPv4 in their Terragraph radios, but to get the full functionality out of the Terragraph capabilities, it does require IPv6. And a lot of people just haven't fully considered that or implemented that in their networks yet. Fortunately, the solution we're using has a neat feature that we can effectively use IPv4 in a bridging mode. And that's been a key enabler for us for this particular deployment. And that allows our customer to catch up with IPv6 deployment in their network. Similarly, in these higher frequencies, from an engineering standpoint, it's not just about distance, but also about alignment. Once you get in the field, aligning these radios is more complex and takes more thought. We've got oftentimes many degrees to work with in the beam width of a microwave dish, but millimeter wave, it's typically less than a degree. So it has to be really right on. One of the neat things that we see in Terragraph is beamforming capabilities, which has greatly simplified alignment, but there are still some intricacies that we've had to learn and train our field crews to become aware of as they start to deploy more and more of these radios. But beamforming is really neat technology that does absolutely make this simpler.
Yeah. So it's simpler, but at the same time, it's not like putting out a Wi-Fi access point.
No, it's not.
You need to have, and like I said, planning is also going to be a little bit more complex than microwave,
right,
for the same reasons.
Yep.
Now, did you work at all with 60 gigahertz before AY? So like the 802.11 AC version of 60 gigahertz?
We had only played with some equipment on the bench to evaluate.
That was enough. Like,
yeah,
okay.
Yeah. And I take that back. We also deployed some equipment in the field, but not a lot of it. Mm-hmm. And there's a lot of great solutions out there and players that have been in the space a long time. And as I think about it, and it occurs to me, we did more than maybe I'm giving myself credit for initially. And what we found is the equipment at 60 gigahertz was really easy to deploy. It was really simple equipment, and it's worked really well in the field and even exceeded our expectation in terms of distance capabilities.
Yeah. Okay, so let's talk about the other verticals you've been working with. So clearly, smart cities, that's there's so much that they can do. There's so many use cases that you can think of. Now, what about public safety, transportation, and utilities?
Yeah, so these are all verticals that we spend a lot of time in and folks we talk to day in and day out. And 60 gigahertz creates some neat opportunities for folks like public safety and utilities. And the primary things that comes to mind is driving capacity in so many networks is simply video. There's more and more demand for video all the time, and not just video, but intelligent video with things like AI being implemented to catch very specific profiles within the frame. And that requires a tremendous amount of data. In the rail industry, I believe that as Terragraph and 60 gigahertz continues to mature and the capability of mesh, our hope is that we see it start to support nomadic endpoints, and not necessarily in our environment mobility in the traditional sense of a handset, but more so moving vehicles, slowly moving vehicles, for instance, cranes. Cranes in a rail yard. So we do believe that there's going to be a great fit for these types of applications in rail yards for crane control, in crane operations and video on the cranes. And then further is offloading large amounts of data from locomotive devices for different sensor purposes once they come to a stop in a rail yard.
Wouldn't be something that works for like construction sites or mining, where you have this sort of like you don't have really a fixed environment, but it's not people driving on the highway.
Exactly. I think you're exactly right, and I think that's the same as the crane applications in the rail yard for sure. And in fact, you mentioned construction. Oftentimes, especially right here in our little town of Castle Rock, Colorado, there's a lot of construction going on. They're building high rises, and there's connectivity across the street from the construction trailer. And we get a fair amount of these types of phone calls. We just need to get across the street and we're not going to string fiber. And millimeter wave is perfect for that.
Yeah. Now, one thing I wanted to ask is, you've been working with different frequency, different technologies. And if you look at the prospect for 60 gigahertz and Terragraph specifically, how does it compare to things like CBRS, and now there is the 6 gigahertz as well? So if you are a city, for instance, what about using CBRS or 6 gigahertz instead? Or do you want to use it alongside?
Well, that's a loaded question. I don't know if I was totally prepared for that one. So certainly access to the 60 gigahertz band is much simpler. It is, there's much more bandwidth available. There's 14 gigahertz. The CBRS band is much more limited than that, less than 100 megahertz available. Even the 6 gigahertz band, maybe a couple hundred megahertz. So there's tremendously more spectrum and hence capacity available. Access to the band is much simpler. There's just
there's no legacy users.
Right. That's right.
You don't have to accommodate other people.
Exactly. You're not competing for airspace, so to speak. But to answer your question, I do believe there's absolutely a hybrid opportunity to deploy both types of systems, maybe with 60 gigahertz serving as the backbone of a dense CBRS deployment, and then also providing very high capacity fixed connectivity to certain tenant users. So I'm thinking about CBRS networks that we're designing right now, and potentially could end up operating, and they're spread over many, many miles, with great distances between the access point of the base station and the subscriber or remote unit. And I'm just imagining how we would provide backhaul of 60 gigahertz and fill in some of the CBRS gaps with 60 gigahertz.
Now, let me ask you a final question. If you look at, say, the next 5 years, and where do you see that your major areas of activities are with respect to Terragraph? And I'm sure that you don't have a plan, but if you were to just have a guess of where would you see the demand coming from? What would you be working on?
Yeah, So I think these public-private partnerships create a unique opportunity where we're truly blanketing cities with 60 gigahertz. And it's the same philosophy that the industry has had for a long time about 5G, perhaps very similar to that. But it will be, Terragraph is just far more perhaps accessible than, thinking in terms of equipment, than necessarily the standards-based 5G equipment. And so I think it's just going to make it easier to have these large kind of canopy blanketed areas over, I'll just say densely populated areas with a lot of 60 gigahertz on every building and light pole and in every window to provide an incredible amount of capacity. That's really where I see it going. I think there will be some neat opportunities in some of these specific market verticals that I described in rail, public safety, utilities. We could see the IoT, the IIoT become more relevant as it relates to 60 gigahertz. That's generally where I see it going, but I just see a lot more of it being deployed.
Yeah, absolutely. And it's interesting because when the Terragraph was initially announced, a lot of people thought that that's like it's for rural areas type of technology. But I think that what's emerging is actually it's in dense areas where it really has that's the biggest market.
One more area, before we move on from that topic, is I believe there's also an opportunity for more 60 gigahertz. Most people wouldn't think of 60 gigahertz for rural markets because it's just too great a distances.
Mm-hmm. Right.
But I do think where folks are considering the deployment of fiber today, fiber to the home in new developments, and we've been involved in some of these types of projects, where the homes are even on an acre or an acreage, those distances are kind of perfect for 60 gigahertz. So rather than dropping fiber to each home, these networks could be stood up very quickly with 60 gigahertz Terragraph in the mesh technology.
Or even just from the street to the home instead of having all this hanging wires, which are really ugly. And
yeah, right. And
they if something falls on top of it, they just,
and there's instant redundancy, and that's the beauty of it. So
that's right.
You basically build a mesh network of homes.
Yeah. Well, and I guess going back to your point of safety, and sort of like mission critical applications, the fact that you have redundancy with when you have a mesh, you just have all sorts of way to manage traffic. That should be a much it would be increasing the value of this solution.
Yeah.
That you can have. So how is this Terragraph going to change the way you do business in terms of your business model? Are you going to work on Terragraph in the same way that you work with other technologies?
I think it's going to create an interesting new opportunity for us. More and more we're feeling this pull into network operations and to actually build something and then turn around, while our customer perhaps owns it, we turn around and operate it for them. And that's the opportunity I see for organizations like mine as it relates to Terragraph. Of course, we're going to hopefully get to keep this, selling equipment and installing it and designing it and to get paid to do all those things. But the greater opportunity for us as a system integrator, I believe, is to become more of a network operator and to create networks that we turn around and get to manage, like a managed service.
That's very interesting. Well, Brett, thanks so much for sharing your thoughts with us today.
It was great. Thank you, Monica. It was my pleasure.
And thank you for watching this. This is part of the report on Terragraph that you can download from www.senzafili.com. And you can also read the transcript of our conversation. Thanks a lot.